Recently, Microsoft has claimed that they are in process of making world's fastest quantum computer. Uh, this computer has computation capability more than the collective capacity of all the available computers on the planet. If their claim is true, then definitely it will be a revolutionary step in the field of quantum computing. Let us understand what the Majorana one is and how they claim to achieve it. So, in order to understand the property of material, we must understand the behavior of electrons in its atom. Since electrons are the quantum particle, therefore they follow quantum mechanics. For a system of one or two electrons, one can easily solve the Schrodinger wave equation and tell some useful information about the system. But for a real material, it is a bit difficult. In this case, multiple electrons interact with each other, and this makes their joint wave function really complex. And that's why we use computer for handling this task. And this is called a material simulation or material modeling. Now, if you are working on a system having n electrons, then you have to keep track of 2 to the power n complex function. For example, for a system having 30 electrons, over 1 billion functions are needed to be calculated, which require a huge computation power and lots of time. Even most powerful supercomputers run out of memory or take unreasonable time to handle this task. So, what is the solution? The solution lies in quantum computer. Let us understand what is the basic difference between classical and quantum computer. So in classical computer, data processing is done through the bits. So these bits, like we can take example of maze. Like we have to solve this maze, and these bits will act like a mouse, and this mouse will inquire every way uh, in order to solve this problem, and finally it will tell us the solution. So the first thing is that it is time taking, and if the maze is a bit more complex, then there will also be some additional hardware requirement for solving this problem. So in quantum computer, multiple bits can exist together. These are called qubits. Qubits are joint state of bits. So for in quantum computer, these qubits will work together to find the solution of this maze. So it is relatively easy and less time taking. What are the challenges with the quantum computer? Noise, reliability, and size. Actually, qubits are pretty delicate in nature. There always has been some issues with their stability. Like if we want to make some really stable qubits, we have to increase its size, which in turn also affect computing speed and size. So what Microsoft has done, Microsoft has used the concept of Majorana particle, whose theory has been predicted much before. It says you could have a particle which is anti-particle of itself, which is called Majorana particle. Like somehow you combine two Majorana particle and you may get nothing. So Microsoft claimed that last year they have been able to observe Majorana particle experimentally, and this year they have been able to control it. And this allowed them to create the topological qubits, which are really compact in size and free from noise and other disturbances. Over a million of these qubits can be fixed on a very small chip. So this is what the Majorana one is. Microsoft has also coined the word topoconductor, which is short form of topological superconductor, to describe the material on which the Majorana one is based. There are also reports of some controversies in Majorana one. Which is centered on the validity of claims about creating new state of matter, which is topoconductor, and the quantum processing unit based on Majorana zero modes. There are two major critiques of that. The first one is from the Business Insider. They claim on behalf of Amazons that the chip can potentially enable future experiment. There is no guarantee of that. And the second one is the preprint on archive, which says that Microsoft approach of detecting Majorana is flawed, and it raises big question on qubit approach of making supercomputer. Also, the Microsoft quantum hardware has been subject of controversy since its high-profile retracted article from Nature in 2018, which initiate both excitement and skepticism in scientific community. So this is all about this Majorana one from my side. Thanks for watching.